Welcome back to geometry. We're going to start at 1.6, measuring angles. First term that we have is an angle. Again, hit the pause button if you need to write all of the following definitions. For an angle, it's going to be formed by two rays. So let's start with one ray. Let's say there's ray AB. And then we have a second ray, and let's say that hits point C and then keeps going on forever. So what we now formed here is an angle, and this could be called angle back, or it could be called angle cab. And so we always have the letter in the middle represent the angle. You could also put a 1 in here and say that this is angle 1. Our vertex point is going to be the endpoint that's shared by the two rays. So in this problem, we have vertex A. And so, here's angle A. This is our vertex angle. All right, we're going to jump down to vertical and adjacent angles next. Let's go and draw two straight lines that intersect. And what I can say is that, let's say that this forms angle 1, this forms angle 2, and this forms angle 3, and angle 4. Well, when I look at adjacent angles first, it's two angles that share a common side. So I have angle 2 and angle 3, those are adjacent angles. I have angle 3, comma, angle 4. I have angle 4, comma, angle 1, and angle 1, comma, and angle 2. All four of these would be considered adjacent angles. Vertical angles are going to be two non-adjacent angles formed by intersecting lines. So that would be angle 2 and angle 4 and angle 3 and angle 1. And those would be our vertical angles. Now, you should know that angle 2 and angle 4 will always be the same measurement. So angle 2 is congruent equal to angle 4. And just like angle 1 is congruent equal to angle 3. And again, those are both vertical angles. And so I put one mark and one mark to show that these two angles are the same. Sorry, this is one mark. And then I put 2 marks and 2 marks to show that angle 1 and angle 3 are the same. Alright, next term we have, we need to draw is two complementary angles. And there's two ways that we can draw this. We can draw adjacent and we can draw non-adjacent. So if I wanted to draw adjacent first, I would have two angles that add up to 90 degrees. So let's put, oops, sorry about that. Here's our right angle. Let's put a box here. And then let's say that I drew a third ray out, and it's going to hit here, and then it's going to keep going forever. Well, I could say that angle 1 and angle 2 are complementary angles because they add up to 90 degrees. All right, then I can do the same for non-adjacent too. For that, I can show that I have let's say a 70-degree angle. And all right, there you go. And then next, we're going to draw a separate angle, and it's going to be a very small angle. And we're going to say that this angle is 20 degrees. And so when I add up 70 plus 20, I would get 90 degrees. All right, then after complementary, we have supplementary angles. And we can do the same thing that we just did. So we're going to do adjacent, supplementary, and non-adjacent supplementary. So here we have adjacent and non-adjacent. for adjacent, we have two angles that add up to 180 degrees. We're going to form what's called a linear pair, but first draw a straight line. And then from this line, we're going to shoot up a ray. And now we've formed two angles from this straight line. So let's label this angle 1 and angle 2. And I can say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And so that would be our case of adjacent supplementary angles. Non-adjacent would be two separate angles. So let's draw an obtuse angle first. Let's say that's 130 degrees. And then I would draw a 50-degree angle. And so what we've now formed are non-adjacent supplementary angles, two angles that add up to 180 degrees. Alright, next, for linear pair, let's just go ahead and write out the term linear pair. And that's the same exact thing as adjacent supplementary angles. So when you see this relationship in geometry where you have a straight line and a ray, it's always, these two angles will always add up to 180 degrees. Alright, last, we have an angle bisector. Remember that anytime you see the word bisector, it means it's going to cut in half. So something will get cut in half, and in this case, it's going to be an angle that gets cut in half. So let's draw a 90-degree angle. Let's do that again. There we go. Let's put our box 90 degrees. And then let's draw an angle bisector. So that'll be a ray that's going to cut that angle in half. And so what we have here is 45 degrees and 45 degrees. And so let's give this name, let's give this ray a name. Let's call it ray AB. And I can say that AB, ray AB is an angle bisector. Alright, next we have how to name an angle. And so we can name an angle with one letter, or we can choose three letters. And then we can also use number 1, 2, etc. when explaining an angle. So when I look at this angle, there's a few different angles that we have. We have angle DOE. So angle DOE would be the same as angle 2. We have angle EOF, which would be the same as angle 1. And then we have, and so I can say that this angle plus this angle is going to equal our entire big angle, which is going to be angle DOF. And remember that, just like in segments, we can say these angles in the opposite way. So I can have angle EOD. I could say that this is angle FOE. And I could say that angle DOF is angle FOD, FOD. One thing to note is that we cannot name this angle angle O because we're not sure what angle O is referring to. Is it angle 1, is it angle 2, or is it the entire angle? And how to measure, we always measure in degrees. Alright, we always measure an angle in degrees. So angle B refers to an angle, and measure of angle B refers to its measure. And angle B does not equal measure of angle B. They are two different things. Recall that AB does not equal segment AB. Okay, they're similar, but they're not exactly the same. All right, angle B does not equal the measure of angle B. This refers to the angle, this is the measure in degrees. Next page, we are now going to classify angles. We first start off with an acute angle. So if we want to draw out an acute angle, it's less than 9 degrees. So it's going to be a small, tiny, acute angle. And so we have an angle that's less than 90. So it could be an angle that is 45 degrees. You could have an angle that was just barely less than 9 degrees, like 89 degrees. Okay, or if you have a really small, skinny angle, let's say that measured 1 degree. Okay, so anything from 1 up to 89 would be an acute angle. A right angle will always have a 90-degree angle. It's also going to have a box, so we will see this box a lot. That means 90 degrees. An obtuse angle means we're going to open up our ray, so we're going to open the angle up, and it's going to be greater than 90 but less than 180. So let's say we have 135 degrees. And a straight angle is always going to equal 180 degrees. So there's my straight line, and we would say that we have 180 degrees. When looking at the term congruent angles, let's say we had two 45-degree angles, and let's say that this was angle A and angle B. Then I can say that angle A is congruent equal to angle B. Or I could also say that the measure of angle A is congruent equal to the measure of angle B. Alright, next. They want us to state another name for the angle and classify the angle by its measure, and then assume that the figure is drawn roughly to scale. Alright, so we need to state a second name, the same angle for angle BFC, and F is our vertex point. So angle BFC looks to be this angle here, so we're going to say angle CFB. Now, it appears to me that this angle is less than 90 degrees. Not by much, but it is. So we're going to say this is an acute angle. Next, angle 2. Here's angle 2, and one of the rules is that you can assume this line is straight, and since this is a straight line, you would know that this angle plus this angle has to equal 180 degrees. This is a linear pair. They're adjacent supplementary angles. So angle 2 has to be 90 degrees, which makes it a right angle. Alright, now we have to name angle 2. Let's name this two other ways. So I can say angle AEF. Or I can even start at B and say that this is angle BEA. Okay, so there's a few different ways that we can name angle 2. Angle 3 looks like to me is going to be greater than 90, so we're going to say this is an obtuse angle. And then it looks like if we were to rename angle 3, I could say angle EFC, or I could say angle CFE. Alright, then angle AED, this is our straight angle, or straight line. So it's going to be 180 degrees. And if I said angle AED, I could say angle DEA. Okay, next, we're being asked to identify a pair of supplementary angles. And I guess for now, let's do a pair of adjacent. So we're looking for side by side. Now, let's recall that adjacent supplementary angles are exactly the same as a linear pair. So whatever answer we get did here, we're also going to write down here, because adjacent supplementary angles, same exact thing as a linear pair. So we have, looking at angle AOB, and angle BOD, if we just kind of ignore this ray, we would see that this box here, we could put a 90-degree box here as well. And so let's say angle AOB and angle DOB. And so let's also put that down for our linear pair, angle AOB and angle DOB. Alright, next, let's put angle 1 here and we'll put angle 2 here. Do you see how angle 1 plus angle 2 is also going to equal 180 degrees? So let's also name, we'll put the and, because this next pair would also be supplementary angles. We can say angle AOE, comma, angle DOE, and those would also be adjacent supplementary. So we're going to do the same thing down here, angle AOE and angle DOE. Alright, moving to vertical angles. We want to find two straight lines that intersect. Remember, on vertical angles, it's always caused by two straight lines. So angle 1 and angle 2 would be considered vertical angles. And then angle 3 and angle 4 would also be considered vertical angles. And we can put one mark here, and then 2 marks, and then 2 marks. So when looking at this shape, I see one straight line and a second straight line. Now a little bit misleading is this ray, so we need to pretend like this ray isn't here and just focus on these two lines. So I'm going to put angle 3 here, and hopefully you see that angle 1 and angle 3 would be considered vertical angles. These angles are the same in measure. So we're going to say angle AOE, comma, angle COD. Those would be our vertical angles. I could also say that angle EOD and angle AOC would also be considered vertical angles. It's the obtuse angle. And again, just ignore AD. Alright, a pair of complementary angles. Alright, so two angles that add up to 90 degrees. Let's put angle 4 here. Do you see how angle 3 plus angle 4 is going to equal 90 degrees? So the only two that work would be angle BOC and angle COD, COD. Alright, and then two congruent angles. Remember that vertical angles are always congruent. So we can say angle 1 is congruent equal to angle 3. And then let's name angle EOD is congruent equal to angle AOC. Our last rule of the day is called angle addition postulate. Let's recall that we had a rule that we learned last unit that was called segment addition postulate. And if we make a drawing to refresh our memory, remember we would say that we have segment AB, and then we also have a third segment that involves C. And so what I can say with the segment at postulate is that AB, the length or the distance of AB plus the length of BC is going to equal the length of AC. And we're just saying that this segment plus this segment is equal to the entire segment. Well, we can do the same thing with angles. So let's draw an obtuse angle this time, although it could be acute or right or even straight. And we're going to draw a ray. And let's label this point B. We'll have this be point A. We'll have OB at the center. And we have point C down below. And so what we're saying on the rule is that if point B is in the interior of angle AOC, then the measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. So the same thing that we did down here on our segment, we're going to do on our angle. We're just saying that angle 1 plus angle 2 is going to equal the entire angle